Hello guys, we are Group 5 for Digital Electronic Design for 2016 first sem, and today we are doing our Lab 3, which is MSI and Sequential Circuits. Hi, I'm Liu Xinyong, and this is labE3, and this is Gong Chuan. They are my teammates. Thank you.
Right now, we are doing part 1 of the Lab 3 project. As you can see here, this is the circuit with three IC, a D flip-flop, a JK flip-flop, and exclusive OR gate IC to construct this circuit, and JA, which is equal to B, and KA needed to be in one input, always in one input. For JB, it is the input from A prime, and KB also same as KA, needed to be in one input, and DC is the output from C and B into the exclusive OR gate. And to get the state sequence, we construct this, we fill in this table state with all the input, and we get the next state, so that we can get this clock sequence in state diagram. So at first, it will be start from 0 to 0 1 0, as you can see here, with 0 0 to 0 1 0, and next 0 1 0 to 1 0 1, and next one from 1 0 1 get 1 0 0, and from 1 0 0 we go to 1 1 0, and the last one is back to 0 0. And now I will show you the result in the prototyping board. As you can see here, the JK, not JK, sorry, is KA and KB, which I mentioned just now, needed to be always one input, so that we can get the correct output of the clock sequence. And first, we set the clock module to 1 Hz, and then the result is shown from 0 0 0, 0 1 0, from the sequence of the state diagram. It is the same as we can see from the LED module, the result of the sequence of the state diagram, with starting from 0 0 0 to 0 1 0, 1 0 1, 1 0 0, 1 1 0, 0 0 1, and back to 0 0 0, as you can see in the LED module. So for the second part of the part 1, when KA and KB has no output insert into the circuits, so we only get 0 1 1 to 1 1 1 output continuously back and forth.
Now we are doing part 2 of the lab
and we are doing the part which we are asked to implement the function with using an add to 1 multiplexer and a single get. And this is what we get from the care mat, and this is a truth table that we obtain. So our circuit is designed like this, as shown in the figure. And in the circuit board, we have connected the multiplexer and the gate together like this. So I will demonstrate the output F now. So it's written that when A, B, C, and D is equal to 0, and the F will be 0. When D is equal to 0, and the output will be 0 as well. And then when C is equal to 1 and D is equal to 0, the output is still 1. Where D is equal to 1 and C is equal to 1, the output of F is 1. And then when B is equal to 1 and D is equal to 1, the output is 1. And when B is equal to 1 and D is equal to 0, the output is 1. And then when both B and C are 1, and then D is equal to 0, the output is 0. And when D is equal to 0, the output is 1. And when A is equal to 1 and D is equal to 0, the output is 1. And when output is A input is 1 and D input is 1, the output is 0. And when A and C are 1 and D is equal to 1, the output is 1. When D is equal to 0, the input should be 1. And then when the input A and B is 1 and D is equal to 0, the output is 0. When D is equal to 1, the output is 1. And lastly, when all the inputs are 1 and D is 1, the output is 0. When D is equal to 0, the output is 1.
Hello guys, now we are doing our part 2 for our lab 3, which is the third one to implement the function f abc equals to the product of sum, which is 0, 1, 3, 6 and 7 by using a 1 to add decoder and a single get. And the get we implement to use is a 3 input NAND get, and from the question we get our cannot map, which is like this, and we get our complement f equals to a prime and b prime, or a and b, or b and c. And by further doing this, we will get our f equals to bracket a or b, a prime or b prime, b prime or c prime. And this is our circuit diagram. And by using our f, we will get our state table, which is like this. And okay, so this is our circuit board, and the first one is our button A, second one is B, and third one is C. and our output is here, and by pressing 0 0 0 and we will get our f equals to 0, and 0 0 1 we are still getting our output as 0, and by pressing 0 1 0 we'll get our output equals to 1, and pressing 0 1 1 we'll get our input as 0, and by pressing 1 0 0 we'll get our output as 1, and by pressing 1 1 0 we will get our output as 0, and lastly by pressing 1 1 1 we will get our output as 0. Lastly, with the inputs ABC equals to 1 1 1 and we will get our F equals to 0 in output. That's all for lab 3. For part 2, the third one. Thank you.